In this video, we will be exploring chemical bonding and the different types of chemical bonds. A chemical bond is an attraction between the charged particles that compose atoms. Like charges repel, just like we would see if we put two positive sides of a magnet together, and opposite charges attract. This can be shown in this figure right here, where we have a red positive charge being attracted to a negative yellow charge. Those colors are arbitrary, and then showing here positive charges repel, negative charges repel each other. This can also be quantified using Coulomb's law. If you've taken physics, you've probably already seen Coulomb's law before, where you have the electrical force is a function of the charges and the distance of separation between those charges. I won't have you doing any math with this equation, Coulomb's law, just here to show you this is the quantitative version, and this is just showing you the qualitative. Great. So in the last video we talked about octets filling the valence electrons, and we talked about how noble gases have a complete octet, and the other elements will lose or gain electrons in order to have a noble gas-like configuration of an octet. So this is why bonding occurs. The octet rule explains this, how atoms tend to gain or lose or share their valence electrons to get to that nearest noble gas configuration. So we saw last video that we could gain or lose electrons to get to that nearest noble gas configuration. So that would form cations or anions, which could then be attracted to one another and form a chemical bond. Or, as we're going to talk about today, they can also share their valence electrons to attain that noble gas configuration. There are three types of chemical bonds: ionic, covalent, and metallic. Ionic bonds are where there's a complete transfer of electrons. Covalent or molecular bonds are where there's sharing of electrons. And metallic bonds are a sea of electrons. And we'll get into each of those. So we'll start with ionic bonds. In ionic bonds, we have a complete transfer of electrons. Ionic bonds occur between a metal and a nonmetal, and this is where it gets important for you to remember where metals and nonmetals are on the periodic table. Let's look at an example of an ionic bond. We have sodium in group 1A. It's a metal. It has one valence electron, reacting with chlorine, which is in group 7A. It's a nonmetal, and it has 7 valence electrons. What occurs here is chlorine takes an electron from sodium, and we end up with a sodium cation and a chloride anion. So now we've produced a cation and an anion, and these are attracted to each other. Because the cations and anions are attracted to each other, they form a crystalline lattice of alternating cations and anions. And just as a review, the metal loses the electron and becomes a cation, and the nonmetal gains an electron and becomes an anion, just as we saw in the previous video. Covalent bonds are where there's sharing of electron pairs between atoms. So this occurs between two nonmetals, and when they're sharing, there's 2 electrons per bond. And this is because there's 2 electrons per orbital, as we saw in the last video. So this is an example here. This is methane. You may see covalent bonds drawn like this, where the electrons are represented as circles. You might also see something like this. We'll see fluorine, again, electrons as dots, so you might see that as forming one bond. You might also see something that looks like this, where all of the non-bonding electrons are also represented by dots. You may see something that looks like this for that, with dots or no dots. And another way to write this is using just a dash to represent 2 electrons. So all of these 4 representations are simply saying this is fluorine bound to another fluorine, diatomic fluorine. One more example is water. You've probably seen this before, where the lines represent sharing of 2 electrons. Let's do that in a different color. And then the individual dots are non-bonding electrons. Great. Metallic bonds occur between metals only, and this is a sea of electrons, where there's the sharing of many detached electrons between many cations. And this is because metals can lose their electrons very easily. So what we have are just a bunch of cations that have lost their electrons, and then the electrons are just moving about in between. So we call this the sea of electrons moving around a bunch of cations. We can also call this delocalized electrons. Chart is similar to a flowchart we've seen before in this class. We have pure substances, and these can be elements. Those elements can just be atomic. Okay, so this would be, and a good example is neon, because this is a noble gas. And it is, and neon, because it, and because neon has an octet, it is stable by itself. These elemental substances could also be molecular, which means that it's made up of more than one atom. An example would be oxygen. So we have oxygen bound to itself in O2. We call this diatomic oxygen. You don't find oxygen, a single atom of oxygen by itself, because it's not going to be stable, because it doesn't have its complete octet. Going to the other side, if we don't have elements, we have compounds. We can have ionic compounds, they're ionic bonds. So sodium chloride is the example that we saw before. This is complete transfer of electrons. Or we could have molecular compounds, where we have covalent attachments between atoms.